The Trinity test, held in the desert of New Mexico, turned night into day and changed the course of human history forever. But how did we get from theoretical physics to a weapon capable of wiping out entire cities in seconds? This is the untold, chilling history of the nuclear bomb. The story begins in the early 20th century, when physicists began unlocking the secrets of the atom. In 1896, Henri Becquerel discovered that uranium salts emitted mysterious rays of energy, what we now know as radiation. This discovery was followed by the groundbreaking work of Marie and Pierre Curie, who isolated radioactive elements like polonium and radium. These discoveries showed that atoms weren't indivisible, as once believed. They could change, decay, and release energy. In 1911, Ernest Rutherford proposed that atoms had a dense, positively charged nucleus. This theory would lay the groundwork for nuclear physics. Then, in 1932, British physicist James Chadwick discovered the neutron, an uncharged particle found within the atomic nucleus. Neutrons turned out to be critical for initiating nuclear reactions. The turning point came in December 1938, when German chemists Otto Hahn and Fritz Strassmann bombarded uranium with neutrons and discovered it had split into lighter elements, specifically barium. This was nuclear fission, though they initially didn't fully grasp it. Physicist Lise Meitner, an Austrian Jew who had fled Nazi Germany, along with her nephew Otto Frisch, interpreted the results correctly and calculated the enormous energy released in the process. Fission was more than a scientific curiosity. It was a potential source of unprecedented explosive power. The reaction released energy based on Einstein's famous equation, E = mc², which showed how a small amount of mass could easily be converted into an enormous amount of energy. As Hitler rose to power and war loomed in Europe, many physicists fled to the United States. Among them were Leo Szilard, Edward Teller, and Eugene Wigner, brilliant minds already considering the military implications of nuclear fission. Szilard, fearing Nazi Germany might develop a bomb, co-authored a letter with Albert Einstein to President Franklin D. Roosevelt in 1939. The letter warned that a nuclear weapon was possible and that the Germans might be working on one. This letter prompted the US government to begin preliminary research into nuclear chain reactions. By 1942, that effort had evolved into the Manhattan Project, a massive, top-secret program aimed at building the first atomic bomb. The Manhattan Project was directed by General Leslie Groves and led scientifically by J. Robert Oppenheimer, a theoretical physicist from Berkeley. It brought together over 130,000 people across multiple facilities: Los Alamos, New Mexico, Oak Ridge, Tennessee, Hanford, Washington, and several universities and laboratories. The scale of the project was unprecedented, costing over $2 billion, about $30 billion in today's dollars. At Oak Ridge, scientists and engineers focused on enriching uranium-235, a rare isotope capable of sustaining a chain reaction. The process required complex machinery like gaseous diffusion and electromagnetic separation. Meanwhile, at Hanford, plutonium-239 was produced in nuclear reactors. Plutonium had similar fission properties to uranium, but was even more efficient for use in a bomb. At Los Alamos, Oppenheimer's team worked tirelessly to design and assemble the bombs. They had to solve numerous technical challenges: how to create a sustained chain reaction, trigger the explosion with precision, and ensure the weapon would actually work. Their efforts led to two different bomb designs. The first was a gun-type bomb called Little Boy, which fired a slug of uranium-235 into another piece of uranium to initiate fission. The second was an implosion-type device called Fat Man, which used conventional explosives to compress plutonium-239 into a supercritical mass. The team conducted the Trinity test on July 16, 1945, to test their work in the Jornada del Muerto Desert in New Mexico. The explosion yielded the equivalent of about 21 kilotons of TNT. It created a blinding flash, a mushroom cloud over 7 miles high, and a shockwave that shattered windows 100 miles away. Oppenheimer famously recalled the famous line, "Now I am become death, the destroyer of worlds." Less than a month later, the bombs were used in war. On August 6, 1945, The B-29 bomber dropped Little Boy on Hiroshima. The explosion leveled the city, instantly killing an estimated 70,000 people. Fires and radiation exposure would push the death toll to over 140,000. 3 days later, on August 9th, the US dropped Fat Man on Nagasaki. About 40,000 were killed immediately, with tens of thousands more dying in the following weeks. Japan announced its surrender on August 15th, effectively ending World War II. The decision to use the bombs remains controversial. Some argue it saved lives by preventing a prolonged ground invasion of Japan. Others view it as a horrific and unnecessary display of force. What's certain is that the world had entered a new, terrifying era, the nuclear age. In the years that followed, nuclear weapons development accelerated. The United States and the Soviet Union tested increasingly powerful devices, culminating in the 1961 Tsar Bomba, which yielded over 50 megatons, 3,000 times more powerful than the bomb dropped on Hiroshima. Treaties were signed to control nuclear proliferation. The Partial Test Ban in 1963, the Nuclear Non-Proliferation Treaty in 1968, and later the Strategic Arms Reduction Treaties. However, tensions remained high throughout the Cold War. Today, 9 countries are known to have nuclear weapons: the United States, Russia, China, the United Kingdom, France, India, Pakistan, North Korea, and Israel. The global stockpile has decreased since the Cold War, but thousands of warheads still exist, many ready to launch at a moment's notice. Scientists and survivors alike continue to warn of the dangers of nuclear weapons. The doomsday clock, supported by the Bulletin of the Atomic Scientists, currently stands at 90 seconds to midnight, the closest it has ever been. It is a symbolic reminder that humanity still lives under the influence of the atom bomb. From scientific discovery to global catastrophe, the history of the nuclear bomb is a sobering story of human brilliance and human recklessness. It began with curiosity about the atom and ended with the power to end civilization. The choice now lies with us. Will we let history repeat itself or learn from it? If you enjoyed this video, please don't forget to like and subscribe to receive more of history's top moments. Your support is greatly appreciated.